Hello everyone, welcome to the modern networking lecture series. This is lecture number 6, and in continuation with the basics or the foundations for the modern networking. In the previous lecture we saw the big data. Now today we'll see about the cloud computing. So these are the techniques, these are the things which have influenced the modern networking. So we'll study now in detail about this. So this is the cloud infrastructure. So cloud computing actually presents an imposing challenges for effective and efficient flow of traffic through the networks. Okay, so this is the cloud infrastructure. Okay, as we can see, this here we have remote users, okay, who are using the cloud service. So here we have a remote user. Okay, then we have some mobile users, okay, who are connected through some wireless infrastructure with the cloud. They are using the cloud service. Okay, then we have a home user using a wired DSL connection, and then we can also have enterprise cloud cloud, or we can have also this, or it can be a data center. Okay, and here we have the cloud providers. Okay, so this is a cloud provider, the cloud infrastructure. Okay, now it consists of you can see the virtual data centers. There can be this virtual data centers which are connected through infra cloud network. Okay, it may happen that the cloud provider may have more than one infrastructure. Okay, this is another infrastructure, cloud infrastructure consisting of various virtual data centers. Okay, and this is the intra cloud. This intra cloud network, this coordinates the network between this virtual data centers of the same cloud. Okay, then we also have this one. This is the inter cloud network. This inter cloud network, it facilitates the communication between these two cloud networks. Okay, then in order to access the cloud, we have this network. Okay, maybe this IP backbone or the internet. Okay, and every data center, this virtual data center, it consists of a pool of resources. Okay, it can be server, it can be storage, media, etc. So this is the cloud infrastructure. Okay, so this cloud service provider, it maintains one or more logical or regional cloud infrastructure, as we saw. Okay, it may have they may have one or more than one infrastructures, and an intra cloud network, it connects the elements of the infrastructure. So within an infrastructure, whatever the cloud elements are there, they are connected through intra cloud. Okay, now this resources which are there inside the cloud, they may be database servers, storage arrays. They can be some other servers which are providing services like firewalls, load balancers. Then we have IDS, IPS, etc. Now intra cloud, they include a number of LANs, and they are interconnected with IP routers. Okay, now within the infrastructure, database servers are organized as cluster of virtual machines, providing virtualized isolated computing environments for different users. So the users, they may not be knowing where they are getting the service from, and ones are maybe divided into various users. Okay, so which using the virtual environment, this is done. Then regarding when we want to communicate between two cloud infrastructures, okay, so we have inter-cloud interconnects. Okay, this inter-cloud network, it interconnects the cloud infrastructures together. So one service provider may have two or more cloud infrastructures. So to connect those infrastructure, we have inter-cloud network. Okay, then this cloud infrastructure may be owned by same cloud provider or by different ones. Okay, so if there are, it may happen that the two infrastructures may belong to a same provider, it may be from two different providers. Then we have a core transport network, is used by the customers to access and consume cloud services deployed within the cloud provider's data center. Okay, now there are two categories of operations support system, as we saw, OSS. Okay, so there are two in this case. Okay, the one is the network operations support system, which we call network OSS, Okay, so the traditional OSS is a system which is dedicated to the providers of telecommunication services. Now the processes supported by network OSS, it includes service management, maintenance of network inventory, configuration of particular network components, and fault management. So these are the things which are supported by the network OSS. Then we have cloud OSS, okay, cloud operation support system. Now this OSS of cloud infrastructure is the system dedicated to providers of cloud computing services. Okay, it is dedicated to cloud computing services, providers of the cloud computing services. So this cloud OSS, it supports processes for maintenance, monitoring, and configuration of cloud resources. So whatever the cloud resources there are, they to manage, to maintain, monitor, and configure this cloud resources, cloud OSS is used. Okay, the cloud, the three network components we have is intra-cloud, inter-cloud, and core. Okay, together with this OSS components, these are the foundations of cloud services in composition and delivery. Now these are the functional requirements for the cloud network capability. So the cloud services, okay, whatever the cloud infrastructure we are using, this must have this capability, must be there. First is scalability. Okay, so scalability means what? The networks must be able to scale easily to meet the demands of moving from current cloud infrastructure of hundreds or a few thousands to networks of tens or even hundreds of thousands of servers. Okay, so scaling means increasing the capacity. Okay, so one of the maybe service provider or any organization, it has to just move from few thousands to more than thousands or tens of thousands of servers. So it would be easy to scale to that needs. Okay, from hundreds to thousands or more than that. So it would be easier to scale. Okay, now this scaling presents challenges in areas such as addressing, routing, and congestion control. Then performance is the second thing. So traffic in both big data installations and cloud provider are very unpredictable, we cannot say. Okay, and they are quite variable. So there are sustained spikes between nearby servers within the same rack and intermittent heavy traffic within a single source server and multiple destination servers. So it may happen that in a cloud, if we have a source like a server, this one of the server may be facing very heavy traffic and others may be facing very less traffic. So intra cloud, it needs to provide reliable high speed direct communication between servers with congestion free links and uniform capacity between any two arbitrary servers within the data center. Okay, so this intra cloud network, it must see that the servers, they have the uniform capacity. Then the topology used in data centers is not well adapted to provide this arrangement. So a more flexible and dynamic control of data flows in addition to virtualization is also required, is one of the desired thing we require. Okay, then agility and flexibility. So the cloud based data centers need to be able to respond and manage the highly dynamic nature of cloud resource utilization. Okay, so this includes the ability to adapt to virtual machine mobility and to provide fine grained control of flows routing through the data center. Okay, then one of the contributors to modern networking is the mobile traffic, as we saw in the previous lectures also. So with the advancement in the mobile devices, they are having rich features. Okay, now rich features means they are able to access fast internet. Okay, there are number of mobile apps, and then we have high megapixel digital cameras. Okay, and we have multiple types of wireless networks such as Wi-Fi, Bluetooth, 3G, 4G. Okay, so these are, and then many number of sensors, they are also one of the mobile, they are also adding to the mobile traffic. So these mobile devices, they are becoming more and more powerful, and they are also making more and more cheap. Okay, and with the dynamic trend in this mobile traffic from 2G to 4G, okay, apart from Wi-Fi and mobile WiMAX, okay, and we are in there is a manifold increase in the data traffic as compared to voice traffic. So if we compare the data if we compare the data traffic with the voice traffic, in the recent years we see that the data traffic has increased tremendously. Okay, now enterprise IP traffic categories. If we see the enterprise network and we compare the IP traffic, there are three categories. First is the mobile data traffic. So all enterprise traffic that crosses the mobile access point comes under the category of mobile data traffic. Then we have managed IP traffic. So all enterprise traffic that is transported over IP but remains within the corporate WAN is the managed IP traffic. And then internet traffic. So all enterprise traffic that crosses the public internet is the internet traffic. Okay, now the chart is not there, but if we compare this three in the recent years, although the volume of mobile traffic is not that much as compared to the other, but the increase in mobile traffic is tremendous, because more and more employees which are working in the enterprise, they are switching to the mobile devices like a laptop or maybe a mobile device, so that they can connect anywhere, okay, to the device. Now next topic is very important regarding the networking, that is quality of service and quality of experience requirements. So these requirements, they must be satisfied. Okay, so generally whatever infrastructure, whether it is traditional infrastructure or modern infrastructure, the main aim is to provide the service. Okay, so how better the service is provided, that we need to quantify, and we need to know what type of quality is given. So two concepts that provide a way of quantifying the network performance. So these are the two things, okay, which can tell whether the desired things are met, okay, whether the requirements are satisfied or not. So one of the thing is quality of service, QoS, and the quality of experience. Now these two parameters, they enable the network manager to determine whether the network is meeting the user needs and to diagnose problems areas that require adjustment to network management and network traffic control. So different services, different applications, they require different types of services. Okay, so whether they are meeting the user needs, okay, whether they are getting the proper service, okay, or whether they are getting that particular service. So if they are not, then we have to diagnose the problem. So we have varieties of applications, like sometimes we have real-time applications, non-real-time applications. So real-time of applications, they require some needs, okay, they require some to run those applications, we need a type of service, okay, and for non-real time we require the different things. So this term must we study the quality of service. Now quality of service, we can define it as the measurable end-to-end performance parameters of a network service. So this quality of service, it can be measured. Now this can guarantee in advance by a service level agreement between a user and the service provider. Okay, so this quality of service, it contains some parameters which are measurable, we can measure it, okay, and it is guaranteed by the service provider that this will be provided, this particular parameters, whatever the parameters, this will be provided. Okay, now commonly specified these parameters include the throughput. Okay, the first one is the throughput, which comes under the category of quality of service. So a minimum or average throughput in bytes per second or bits per second for a given logical connection or traffic flow. So we can measure the throughput. So some of the services, they require, that is the minimum. So throughput should be above that. So if it goes below that throughput, then the service may hamper. Okay, then the delay or the latency. Okay, so the average or maximum delay which can be which can be we can say given to the service. Okay, which can be if the delay goes beyond that particular maximum value, then the service the service will hamper. Okay, then we have the packet jitter. So how much maximum allowable jitter will be there. Then the error rate. So typically maximum error rate in terms of fraction of bits delivered in error is given. Okay, then we have the packet loss, how many packet losses can be sustained. Then the priority. So a network may offer a given number of levels of priorities. Then the availability, so it is expressed as the percentage of time the available. Then security, so different levels or types of security may be defined. Okay, so these are some of the parameters which give us the quality of service, and all these parameters, they are measurable. We can find their values. Now quality of service of course can offer a powerful way to allocate processor, memory, input, output. So this quality of service, it can, by knowing this particular thing, quality of service, the parameters of the quality of service, we can allocate the resources such as the processor, memory, input, output, and network to give the proper service. Okay. Then next is the quality of experience. Now quality of experience is a subjective method of performance as reported by the user. Now this quality of experience is concerned with the user. Okay, so this relies on the human opinion. So if the service is delivered, then we can ask the user how the service was. Okay, so this opinion is given by the user, and of course we cannot measure this. Okay, so quality of experience is important because when we deal with multimedia application, multimedia content delivery, so how the delivery was, what the quality of the voice, how was the voice quality, how was the video quality. While QoS processes do not take quality of service processes do not take into account the user's perception of the network performance and service quality, but QoE, that is the quality of experience, it augments the traditional quality of service by providing information regarding the delivered service from the end user point of view. Okay, so quality of service, whatever we are measuring from quality of service, it is not from the user's point of view, user's perception, but quality of experience, it is from the user's point of view. Okay, now these are some of the factors and features that can be included in a requirement for quality of experience. First is the perceptual. Okay, now this category, it encompasses the quality of the sensory aspects such as the sharpness of the video, the brightness, the contrast, the flicker, the distortion. Then we have the psychological factor. Now this category deals with the user's feeling about the experience, like if that person is using some service or the application, so how ease of the use, joy of the use, then usefulness, perceived quality, satisfaction, etc. Then interactive, so this category, the last one is the interactive experience. So this category deals with the aspects of an experience related to interaction between the user and the application of the device. So how fast was the responsiveness, okay, and the naturalness of the interaction, communication efficiency, and accessibility. This come under the category of interactive experience. Okay, so next we come to the routing. Now that's all for this particular session. We will stop here, okay, and continue with this topic routing in the next session. Thanks for watching.